Good morning, students. Welcome to Good Samaritan School online classes. Good. In the last classes, we discussed some of the questions in Zoom classes, and most of the students are asked some questions, and I hope you all cleared your doubts. And today, we are going to learn a new topic: how strong are acids or base solution? Okay, how to check this whether the solution is acidic or basic. Maybe we have learnt on indicators, so we know how to test an acid or a base by using indicators, and we know that there are some natural indicators as well as some artificial indicators. But today we are going to discuss about a new thing, that indicators are used to test whether an aqueous solution is acidic, basic or neutral. Mostly we discuss like this: acid changes the blue litmus to red and base changes the red litmus to blue. Let me show you how the blue litmus and the red litmus paper looks like. Maybe you have seen this in lower classes. I'll show you once again. This is how the blue litmus and the red litmus papers looks like. This is a blue litmus paper. You can see that the paper are all blue in color, and this is how we can dip this paper. Take one paper and then dip that paper in a acidic solution so that it will change the blue litmus to red color. Okay, and this is what red litmus paper, and this looks little pink color, but it is actually a red litmus paper. But if you dip this paper in a base solution, it changes the red litmus to a blue color. This is how the red litmus and blue litmus looks like. But what happens if these two indicators are dipped in a pure water? But in pure water does not affect the indicators. So in pure water the color remains the same. Why and what is the reason? In water, number of H plus ion is equal to OH negative ion, right? So you can see that H plus ion indicates yes acidic character and OH negative ion indicates basic character. If these two things, acidic as well as basic nature, comes together and equals themselves at one point, then it become a neutral. This is what actually neutralization reaction. Maybe the last classes we learned what is neutralization reaction. When acid and base combine to form salt and water, neutralization reaction. Okay, in acid what happened? H plus ions are greater than OH negative ion, and this is also one of the question I asked you in Zoom classes, that is it possible that basic solution will also have H plus ion? This is what are the questions I asked. Yes, base also contain H plus ion, but the H plus ion content in base is very less. That is what here, base OH negative ion are greater, lots of OH negative ions are there, and H plus ions are very less. That is why we are named them as a base. In acid, H plus ions are very much, that means lots of H plus ions are there, and that is why OH negative ions are very less. That is why they are said to be acidic, right? To understand this concept, if you have a book with you, turn to page number 25. You can see here, yes, the second paragraph here, the scale for measuring hydrogen ion concentration in a solution is called our pH scale, and this has been developed. And why they have developed this pH scale, and what is actually pH? pH, that P stands for potence. It means, it is a German word and it indicates power. Okay, what is this? Why this kind of new pH scale was introduced? To identify the presence of H plus ion concentration. Okay, you can look at it. The first Danish biochemist professor, the professor name is Sorensen. In 1909, he was the first person who started this pH scale and introduced pH scale. And we know that what is pH? It is P stands for power, the power of hydrogen in a solution. If you take whatever solution it is, it can be an acidic solution, or it can be a basic solution, or it can be a neutral one. Whatever it is, we are going to test the power of hydrogen in that, because even acid also contain hydrogen, base also contain hydrogen, even the neutral solution also contain hydrogen in that. So we need to find the power. Okay, how we use that? Okay, he used the scale called pH scale, which is given here. I am going to read from the third paragraph. Okay, we'll start from the second paragraph, third line. On the pH scale, we can measure pH from 0, that means very acidic. 0 is too acidic, and 14 is too basic. pH should be thought of simply as a number which indicates the acidic or basic nature of the solution. Okay, higher the hydronium ions concentration, lower is the pH value. If it is a strong acid, that means heavy concentrated acid, that is why they say that higher the hydronium ion concentration, strong acid, then the pH value will be very less, 0 to 1 and 1 to 2. This is the value. The pH of a neutral solution is 7. Always the 7 always indicates the neutral. Okay, this is the pH scale. Let me tell you what is this pH scale. pH scale looks like this. That means it starts from 0 and end with 14. So we have 0 to 1, 2, 3, 4, 5, 6, 7, 8, 10, and then 12, 14. And 0 to 7 is always acidic, strong one. That means this is how we learned now. If the higher the hydronium ions, if it is a strong acid, then the pH value is very less. That means it comes as 0 to 1. The value will be only here. If the pH is, in other words, if the hydroxide ion is more, that means base is there, then it shows here 13 to 14. That means 7 to 14 is basic, 0 to 7 is acidic, 7 to 14 is basic, and 7 is always neutral. We all know that when acid combines with base, then when they both mix together, we are going to get a salt plus water, and this is what basic in nature. So when the pH is less than 7, then it is acidic solution. If the pH is greater than 7, then it is a basic solution. If the pH is equal to 7, then it is actually a neutral solution, right? So this is what actually pH scale, and here it is given in your book also, page number 25. I want you to read this complete page number 25, and also page number 26. Okay, last paragraph. As the pH value increases from 7 to 14, it represents an increase of in OH negative ion concentration of the solution. So when it is 0 to 7, as we know that it is acidic, and when it start increasing, you see that pH value increases from 7 to 14, that means it represents the increase of OH negative ion. So that is increase in the strength of alkalis base. Generally, paper impregnator with the universal indicator are used to measure pH. So normally, even in our school, we used to have a paper that we name them as a universal indicator. Let me show that. This is what a pH paper looks like. And this pH paper is also having some of the colors also there. You can see 1, 0 to 7, right? It's written, and the colors you look at that, and after 7 you can see 8, 9, 10, 11, 12, 14. You can see some of the colors, and this is how the color it indicates, and the paper color is little yellowish. So we are going to take a strip from here and do some test with by using this pH paper, and this is also named as an universal indicators. Okay, I have made a tabular column. It's also given in your book, and we are going to do a test by using a pH paper. Okay, here I have mentioned 1, 2, 3, 4, 5 vinegar. You can also try if you have a pH paper in your home, but I am going to do only 3 tests. One with lemon, another with soap. Actually, soap I didn't mention, but soap indicates the base. And then even you can try with saliva also, and also I'm going to try with the water. Okay, let's see what happens. Okay, students, I have taken 3 things. One is water, drinking water. This is the lemon one, and a small piece of soap. Okay, and we are going to try this pH paper, that is an universal indicator pH paper, by 3 of this. Okay, let me see what happens. Okay, first I am going to take a strip of this pH paper, the universal indicator, and I am going to dip this in a water, normal water. Actually, what happens when a distilled water is mixed with the pH paper, it shows a light green color. Maybe through this video I don't know how many you can see that light green color, but actually it changes to a very light green color, and it shows that it is neutral in nature. Okay, and I am going to take a test with lemon. Okay, I have cut a small piece of lemon, and I am going to squeeze it in a pH paper, and it shows a very light pink color, and this light reddish or a pink color indicates, yes, presence of acidic in that. You can even try with vinegar also. Okay, the next thing is with soap. Okay, let's see what happens with soap. I moisture this soap a little bit so that it will react with that. When it reacts with soap, it gives some of these blue or a dark greenish color. Can you look at it? A dark bluish or greenish color, which shows that presence of a base in it. Okay, if you have a book, you turn to page 26, and you can see the some of the color or only this is a rough guide actually. Okay, you can identify some colors. Okay, this is first we tried with water, and it shows the color with because it's water, it is actually 7 neutral. And this is we done an experiment with acid, that means lemon, and you can see that it is getting color like this, maybe range is 2, right? And this is the pH paper we tried with soap, and you can see that some of the color which is very closely related to here. Can you see that? So what we are understanding from here is this, using this indicators like pH paper, we can test both acidic, basic as well as neutral solutions. Okay, in your book, page number 26, there is an activity is given here. You can go through this activity. Test the pH value of a solution given in table 2.2. There are some solutions are given, and if we see the compare the color changes by using the pH paper, and we need to indicate what approximately the pH value. So if it comes here like the color comes here at 1, so we have to mention as 0 to 1, that is the approximate pH value. And what is the nature of the solution? If the color comes here, yes, it is acidic. If the color comes exactly here, always pure water and blood always have a pH of yes 7, that means it's neutral. And even you can try with milk of magnesia. Everyone have an antacids in your home, right? Gelicyl or digen, whatever solution, and it is always a basic in nature. And sodium hydroxide solution is acidic, basic. And you can also try with lemon juice, the juice that even sometimes you can test with the saliva. Once you drink lemon juice and you can test with the saliva, immediately you can see the change of color comes only in these color, because your tongue changes to acidic in nature. Okay, if you drink some water and after some time you take a test with your saliva, then it turns into a neutral one. Okay, this is the test, and actually this is one of the important topic in practicals. Also we are going to have a topic called pH of solutions. Okay, your same thing what I did now, you're going to do the same thing in your practicals also. That means taking a pH paper and take a drop from an acidic solution and put a drop on the pH paper, and then immediately if it changes the color, then you need to compare with the chart, and then once the chart you can compare, and then you can write the pH range. That's it. Okay, students, today as we learn then how the pH of solution works, and what is the actual, what is pH of solution, and what is the reason we are using these universal indicators. Okay, hope you all understand the topic properly, and I will see in the next class. But what we are going to do is, from the Monday we are going to write a test. The test is from page number the starting from the chapter page number 17 to page number 26. From this pages only we are going to have a test, and the test will be only MCQ based test, and I will give you a Google form in that, and in that itself you can write a test and submit. Okay, students, if you have any doubts on this topic we learned today, please ask questions in WhatsApp. Hope you all have a good day. Have a nice day. Thank you.